Welcome to the section on completing the square method of solving quadratics for the bell ringer. Let's factor these two guys. Okay, hopefully you recognize that x squared and 25 are perfect squares. So this is going to be x plus 5 quantity squared. And in the back, we also have perfect squares in the front and back. In the front, it's 3x, and then in the back, it's 4 quantity squared. So if you FOILed both of those, you'd end up back with the quadratic that we began with. So again, this is section 12.6 in the textbook, and it's about completing the square, a fourth method of solving quadratics. So if you have a perfect square trinomial, like x squared plus 4x plus 4, which can be factored to x plus 2 quantity squared, still equals 25. We could actually take the square root of both sides of this to solve this. Even though there's a b term, when we have a perfect square trinomial that allows us to take the square root of both sides, which would give me x plus 2 on the left and plus or minus 5 on the right, then I could solve this as x plus 2 equals negative 5 or x plus 2 equals positive 5, because that's what plus and minus 5 mean. So now I have two little equations here that I can solve separately by subtracting 2 from both sides, and I get negative 7 and 3. So it's really convenient when we have a perfect square trinomial because it allows us to use the square root. Here's another one for you to try. Okay, I have x minus 7 quantity squared equals 25, taking the square root of both sides, plus or minus 5. So x minus 7 equals negative 5, and x minus 7 equals positive 5. Adding 7, x equals 2, and x equals 12. So those are my two solutions. Sometimes when we don't actually have a perfect square, we can create a perfect square if we put the right c in the back. So, for example, if I had x squared minus 12x, what c would I need for this to be a perfect square? Well, you can always find that by taking half of the b term and squaring it. So for instance, if my b was negative 12, half of negative 12 is 2 squared gives me 36. And this is then a perfect square. This is x minus 6 quantity squared. And if I had that on one side of my equation, then I could take the square root to solve it. Okay, so for example, if I had x squared minus 10x, what c would I need in the back for this to be a perfect square? Well, my c in this case would have to be half of my b term squared. Half of negative 10 is negative 5. Squared gives me 25. Here's one for you to try. In this case, half of 6 squared gives me 3 squared, which is 9. That's what I need in the back here. Okay, so let's apply it actually. Here I have a quadratic that isn't a perfect square because half of 4, negative 4 is 2, squared is 4, so that's not the correct c for that to be a perfect square. So what I like to do is take this 2 and put it on the other side of the equation. So this becomes x squared minus 4x on the left, and I have to subtract 2 from both sides, gives me negative 2 on the other side. And now I need to figure out what c term I need there for this to be a perfect square on the left. But just like any equation, whatever I add to the left, I also have to add to the right. So what term do I want to use here? Well, my c is going to be half of negative 4 squared. Half of negative 4 is negative 2. squared gives me positive 4. So I want that to be a 4. And if I add 4 on the left, I have to add it to the right. Now I have a perfect square on the left. That's x minus 2 quantity squared. And on the right, negative 2 and 4 is positive 2. Now I can take square roots because x minus 2 is a perfect square. So this becomes x minus 2 on the left, and on the right I'm taking the square root of 2, which is plus or minus 2. So x minus 2 equals negative radical 2, and x minus 2 equals positive radical 2. Add 2 to both sides. Let me erase that guy. Grab my eraser. X equals positive 2 minus radical 2, and x equals positive 2 plus radical 2 are my two answers. Here's one for you to try. Okay, so this isn't a perfect square because half of 8 is 4, squared is 16. I need 16 in the back for this to be a perfect square. So let's put the 9 on the other side. X squared plus 8x plus something is going to be, I had to subtract 9 to get it over here, plus that same something. Half of 8 is 4, squared is 16. So I'm going to put 16 in the back to create a perfect square. X plus 4 quantity squared is on the left, and negative 9 plus 16 is 7. Now I can take the square root of both sides. X plus 4 equals plus or minus radical 7. That means that x plus 4 equals negative radical 7, or x plus 4 equals positive radical 7. Subtract 4 from both sides. Negative 4 minus radical 7, and x equals negative 4 plus radical 7. And those are my two answers, my two solutions to that quadratic. Thank you for listening.